Hello everyone, we do hope you are doing well. Welcome to our channel. This is the first video on 555 timer IC series, and today we will explore how to make a simple LED flasher as the one currently showing on your screen. Let's see how we can actualize this simple circuit on a breadboard, but before that, let's have some background of the 555 timer IC. Welcome back once again and thank you for staying with us. 555 timer IC is a very versatile chip available as a dual inline package. Its internal construction is as shown on the screen. As you can notice, there are three 5 ohm resistors from where the IC derived its name. You can also see how other components are internally connected to give an 8-pin IC that you can use in almost any application. With reference to the notch, the first pin on the left is the ground pin while the opposite one to the right is the voltage input pin. This particular IC can operate with a wide voltage range from 3 volts to 18 volts. However, you should check specifications on the 555 timer IC you are using from the datasheet. Other pins are as shown on your screen. We cannot talk all about this IC since we intend to keep this video as short as possible. Fortunately, there are a lot of information online that you can refer to if you want to learn more. But before we get into today's main topic, let's quickly mention some of 555 timer IC applications. The list is endless, and here is a couple of them. Making of duty circle oscillator. Providing accurate time delays. As a flip-flop element. DC to DC converters and voltage regulators. Voltage to frequency converters. Lamp dimmer. Frequency converter, and a lot more. 555 IC can be operated in different modes depending on the application. In today's episode, we are going to construct an LED flasher with 555 timer IC configured as an astable multivibrator as shown in the circuit diagram on your screen. For construction, we will use one 555 timer IC, R1 of 200 ohms, R2 about 1k ohms, R3 about 330 ohms, C1 470 microfarads capacitor, and a 12 volts power supply. Pin 5 can be connected to a low value capacitor to prevent it from picking electrical noise. However, it's not necessary in this application. Let's build it. It is important to note at this point that there is no recommended order of connecting the components provided you have all the connections shown in the circuit diagram. Place 555 timer IC on the breadboard as shown. Connect pin 8 to the positive VCC. Connect a 220 ohm resistor between pin 8 and pin 7. Connect 1k ohm resistor between pin 7 and pin 6. Short pin 4 to pin 8. Short pin 6 to pin 2. Connect 330 ohm resistor from output pin 3 to LED and to the ground rail or negative power supply terminal. Observe the polarity of the LED. The longer terminal is always positive and the other negative. Place 470 microfarads capacitor between pin 2 and the ground. Connect pin 1 to the ground. Power the breadboard and there you go. Do you notice how nicely the LED flashes? That's because we get a near perfect square wave out of the 555 timer IC output pin 3. Fortunately, you have control over how fast you want the LED to flash or turn on and off. You can do that by playing with the values of C1, R2, or both. Let's see that in action. Replace the 470 microfarads capacitor with another of a lower value. Let's say 100 microfarads. Now notice how fast the LED flashes. It is turning on and off at a much faster rate than when using the 470 microfarads capacitor. The simple explanation for this scenario is that a lower value capacitor takes shorter time to charge and discharge, hence the higher rate of blinking. You can also achieve the same effect using R2 of a lower value. In this case, let's replace it with a potentiometer or variable resistor to give us control on the go over the 555 timer IC. Remove R2 from the circuit diagram. Connect pin 7 to one of the outer pins of the potentiometer and pin 6 to the middle pin. Power the board and turn the knob to see how the flashing rate of LED changes with each turn in either direction. The explanation once again comes to the amount of charging current passing through to C1. Higher resistance leads to less current flowing through, which results into a lower charging rate for the capacitor. That causes the LED to flash much slower if R2 value is increased. The reverse is also true. But what if you want to design an LED flasher circuit with an accurate frequency of output? Some applications demand a specified frequency or time interval. No worries. You can always use the formula on your screen right now to calculate the values for a known frequency, C1, R1, and R2. You will, of course, have to make a correct guess of two parameters and then calculate the other. And since R1 has the least significant effect on the circuit, we recommend choosing an appropriate value for it. Again, you can easily build a resistor network for any calculated value of R2 compared to a capacitor network. So, the rule of thumb is to always choose R1 and C1 for a given output frequency and use those values to compute R2. Thank you for watching this video and please subscribe to our channel and turn on that notification bell to be notified every time we upload a new video. We make several videos a week and we encourage you to always come back to find more on 555 timer IC and other projects. As mentioned, this is our first video in this 555 timer IC. Up next is building a circuit to give the results on your screen. This video might already be out depending on when you are watching this first episode. Do check it out on our channel and see you there.